Being asked to do a binomial expansion here, so here is the formula. General formula when we've got n is like a nice whole number, a and b can be whatever really. So in our case, a is going to equal 1 and b is going to equal 4x because we're being asked to use ascending powers of x. And then of course n is equal to 7. So for us, it's going to become 1 plus 4x to the 7 is going to equal 1. It's going to be 1 to the power 7 plus 7. I'm going to write it as 7c1. You can leave it in this format if you prefer. And then times 1 to the power 6, so that I don't need to write that down, and then it's going to become just x. So that I've got two terms, and then it's going to be 7c2. Again, 1 to the power, what is it going to be this time? 5, and then it's going to become b squared. So just realized I've made a mistake actually, which you might have spotted. It should be 4x here. Very easy to miss that. Okay, careful. And then finally it's going to become 7c3 4x cubed. 7c1 is actually just 7, so I'm going to get 28x. Of course, you can check these things out on a calculator if you want. You can even do it by hand. I'll show you that in a second. So 7c1. You always just get the number by itself for this sort of one because it's going to be 7 factorial over 7 minus 1, which is 6 factorial, 1 factorial. So these mainly cancel down to give 7 because 7 factorial is 7 times 6 factorial. I'm not going to get into lots of detail here. This is a calculator question, but having an understanding of where these come from, like this here, is valuable. The next one, 7c2. So I get 21. And I'm going to times that by 4x all squared. That's going to become 16x squared. And then 7c3 is 35. 35 times 4x cubed, or 4 cubed is actually 64. Of course, you can work that one out, but 64x cubed. Tidy it up. Okay, and this is the great thing about the binomial theorem. Essentially, it allows you to work this out. It's not very nice numbers, but really quite quickly. You don't want to be expanding all those brackets out. So there we are. First 4 terms. Okay, in part B, we're told that the expansion of this, the coefficient of x squared, is 1001. Find the value of a. Right, let's put it together. So I've got 3 plus ax, and I'm timesing by this, but I'm going to write down my binomial expansion. This is part 2. Actually, that is enough terms because I'm only interested in the coefficient of x squared. So how can I get an x squared? Well, it's going to be if I multiply 3 by 336. I'll put the x squared in there as well. Or this one here. Okay, so I didn't need any cube terms because there's no way I could get a squared from it. And when I multiply this out, it's going to become 28a x squared. And that is going to be, actually, I'm going to use the identity symbol here because it's true for all values of x. That's going to equal 1001. So essentially, it must be that 3 times 336, which is 1008, plus 28a, oh, by the way, there should have been x squared there, is identical to 1001. Therefore, 28a is identical to -7 if I minus 1008 from both sides, and a is going to be -7 over 28, which is simply -1/4. So that's my answer. I hope that makes sense. I've used my expansion from part 1, absolutely essential. I've looked at how I can get the x squared terms. I've got them, I've added them together because that's what you would do. I've essentially set it identical to this 1001 x squared because I'm told the coefficients, and then I've set the coefficients equal, like this plus this is equal to this, and I've solved the equation.